Merci. Thanks a lot for the organizer to invite me for the COT SD. I need a slide. Can I have the first slide, please? Est-ce que je peux avoir la première diapo? Si elle n'est pas perdue. Non? Ça y est. Okay, so I would like to speak, to explain a little bit what we do in Amiens and how we consider the early development and what we developed to analyze what's electrically and okay. And so how does it work in the premature neonates at the very, very early stage of development? C'est celle-ci. No. So if we look at the brain of the, during the development for premature, you can see that the brain at 25 weeks of gestational age is a kind of lysencephaly. I mean, there's no girification, and the girification is really minimum. And if you look at the development between 25 weeks and term and 40 weeks gestational age, you see the folding of the brain and the huge increase and the dynamic of the maturation of the brain. Whereas from the term to adult, it's something which is more, looks like to be more linear. And there's a lot of things going on, I mean, during this period between 25 weeks and term. There's cellular proliferation, the migration, the differentiation of the cells, the selection and reorganization of the synapse, the gyration, the immunization. There's a lot of things. And you can see the dynamic on this graph in which you have the age over here, and this is birth. And all these processes are going on with different time delay. So if you want to look at the brain of the premature, of course you can look at the structure and the function. For the structure, you can have the MRI and the CT scan, but you cannot put a premature baby inside the scanner just for the research purpose. You have the EEG to look at the electrical activity. You have the near-infrared spectroscopy to look at the hemodynamic activity in response to neuronal activation. You have the MEG, the magnetoencephalography, the fetal magnetoencephalography. There's not so many fetal magnetoencephalography in the world. There's two, one in Tübingen and one in Little Rock. And we are developing one in Amiens to look at what's going on in the brain of the fetus. You don't have access to the metabolic imaging like TEP and SPECT and fMRI. And you have the ultrafast ultrasound, which is a new technique, which is now developed. So if you look, so what we do is I would like to go back. Yeah. So what we do, we look at the EEG, which is the strategy to look at the strategy of the neuronal networks with a time resolution of 1 millisecond or something like this. And we use the near-infrared spectroscopy. For the near-infrared spectroscopy, what you do is you launch photon. It's exactly the oximeter, the pulse oximeter that you have in the finger when you go inside the hospital. But what you look at is a change in the concentration of oxygen on the hemoglobin, and to look at this, and you look at the dynamics. So it's a relative change in the oxygen concentration inside the brain. So you have an emitter and a detector. You launch photon over there. The photons are going to the brain. They are absorbed or not by the HBO. And according to the level of HBO, the concentration of absorption is increased or decreased. And so that's what you look. It's like the fMRI, in fact. So what you have with the EEG is something like this. You have the response immediately. And to look at the fMRI of the fNIRS, you have to wait 1, 2, 3, 4, 5 seconds to get the response. So it's fMRI like fNIRS is a secondary evaluation of the brain activation. But it's interesting because it's a high spatial resolution. If you look at the EEG of 16-year-old children, that's the typical EEG, and you know it. You have the alpha activity, which is blocked by the opening and closing of the eyes. If you look at the preterm activity of the brain, this is the activity of the brain in preterm, in 24-week gestational age preterm. So can we go back to the previous slide? Now the previous one. Yeah, maybe I can do it. So this is 16 years old, normal. And this is 25 weeks gestational age, normal. So what the brain can do, so what is the ability of the brain at 25 weeks gestational age? And that's our question. So to do that, we use the EEG, and we use the high-density EEG. We put 128 channel recording on full-term neonates and from 32 weeks gestational age. And before 32 weeks gestational age, we design specific caps to put 64 channel EEG on and to try to see better what's going on inside the brain. So this is the high resolution in premature with 128 channel at 30 weeks gestational age. So there's a lot of information. And in fact, there's too much information for our eyes and our brain. So we will need in the future, we will need, brain, artificial intelligence to treat this information because that's really too much. But let's see. The context is that the organization of the brain is different between premature and full-term neonates. We have something which is quite specific, is the subplate. And the subplate is a transient structure beneath the cortical plate, and which is a kind of relay of information during the development, which disappear at term. At term, there's no more subplate. But before term, it's in yellow over here. It's a huge structure in premature. And it's really important because it's a key relay for the thalamic afferent before 28 weeks gestational age. And at 28 weeks gestational age, the thalamic afferent are relocated from the subplate to the cortical plate. And this is important because 28 weeks gestational age is the time that the cortical neurons connect to the external world. Je vais le tuer celui-là. So if we look at the subplate, this is the cortical plate, the subplate, the thalamic afferent, and before 28 weeks gestational age, you have this subplate, which is a key relay for the cortical plate neurons between the thalamic afferent and the cortical plate. And then at 28 weeks gestational age, we have the thalamic afferent that connect directly to the cortical plate. So there is a kind of important interaction, transient networks, including the subplate, that is involved in the treatment of information arising from the environment. This is the dynamic also of the maturation of the brain. If we look at the electrical activity of the brain, and we can separate that in two, maybe. There is something which is called what we call network-based. That means the discontinuity, the synchrony, the dominant frequency and the amplitude of the activity that progressively develop between 24 weeks gestational age and term. And there's the other part, which is maybe more interesting, is the generator-based activities. That is, it's specific activities that occur at a given time of the development of the brain. And the reason is why there is this activity, what is the job of this activity. And we were interested in the thalamic theta temporal activity in yellow, which occur between 24 weeks gestational age and 32 weeks gestational age in the temporal areas. So this is the generator that we are working on, the theta temporal activity in coalescence with slow wave, and the delta brush, the slow wave with rapid activity on the top of that. This is known for the 1950 roundabout. But what we looked at, first is the theta temporal activity in the slow wave. And what we looked at, I mean, these two activities, the theta and the slow wave, are in kind of coalescence. That means they are, and there is an intimate relationship between the two types of activities. And the rapid activity occurs, this rapid activity over there, occurs always, I mean, in the descending slope of the slow wave. So it's a kind of well-oiled horlogerie of, between the two activities. And this evolved in the course of development between 26 weeks and 34 weeks gestational age. And there is a kind of change in the phase amplitude coupling of the neuronal activity. So we consider this as a carrier of information, and this as the information which is transmitted in a given area. And the idea is that this type of generators, spontaneous generators, build the system and build the connectivity of the system. They play a role in the organization, in the synaptic organization, in the maturation, in the cell death, and so on, in the area where they are located. We checked also for the connectivity of this theta temporal activity, and we show that they were involved in the wiring of the perisylvian area before auditory activity arising from the cochlea arrived to the cortex. So it's a kind of something that prepares the network to receive the information which will arrive at 28 weeks gestational age. Then we looked at the delta brush, which is another activity in which there is a coalescence between the slow wave and the rapid activity, but it's different in terms of frequency, in terms of slow wave, in terms of phase amplitude coupling, and it's probably, if we look at them, they occur in different areas. In green, it's the theta temporal activity. In blue, it's a delta brush. And if you look at this, they occur in different structures, in different areas. And they occur at the same time, but probably the delta brush are involved in the treatment of the information arising from the periphery. We checked also for frontal activity, and we looked at what occurs in the frontal area during the development at different periods of development. And there is different type of features. There is the FTA, SW, whatever the name, the delta brush, and the frontal transient at 40 weeks gestational age, 32 weeks gestational age, and 27 weeks gestational age. And this, I mean, is a kind also of looking at the development, looking at what this type of generator are doing. I mean, we don't know too much what is their function. But it's like if you have a house. You want to build a house. You first do the wall. Then there is the painter. Then there is the electrician. Then there is the roof and so on. But you have something to be really well organized in the good direction. I mean, not the electrician coming before, I mean, the painter, or the electrician before the... It doesn't work. So it has to be well organized in time, with good delay, with good organization, and trying to understand what's going on inside the brain at this different period of development. If we look at the frontal transient, this frontal transient activity in the frontal areas, I mean, if we looked at them and tried to locate them, we found them located, I mean, in the in the frontal area, in areas that are involved, I mean, in odor perception, in the treatment of the odor. And we hypothesis, and this occurs, so this frontal transient exactly around term, between 36 weeks gestational age and 42 weeks gestational age. And so our hypothesis on that is that it might be implied it's a mother attachment. And it's just at the period of the delivery. So this, I mean, c'est en français. Ça fait du bien le français aussi. Ça fait du bien de parler en... C'est plus simple, hein, je ne voudrais pas dire, mais quand même. So these activities are related to spontaneous generator. We know from animal studies that they are involved in synaptogenesis, in myelization, in the neuronal migration, in the neuronal guidance, differentiation cellulaire. So, I mean, they have to be well organized. The phase relationship between the rapid activity and the slow activity has to be respected, and because of the organization of the brain. And a grain of sand, I mean, inside this well-oiled horlogerie, I mean, is a problem for neurodevelopment, I mean, later on. And it might be involved in neurodevelopmental disorder. That was for the endogenous activity of the brain. But now the question, the initial, I have time? I still have time. But now the initial, 5, wow. The initial question was what this, I mean, immature brain was able to perform from 25 weeks gestational age. So we didn't go so early, but we go to 30 weeks gestational age. And I have some questions, and you will raise your hand. Okay, the first question is the network at 30 weeks gestational age, the time that the brain is connected to the environment because there is a relocation of the thalamic afferent to the cortical plate. Is the network able to discriminate phoneme between ba and ga? Yes or no? Who says yes? Who says no? Okay, who says I don't care? Neither. Okay, the second question, to discriminate male and female voice. Yeah, that's better. It says yes and no. Okay. The mother from a stranger voice. 30 weeks gestational age. Huh? Okay. Rhythm. Okay. And the beat and meter frequency in rythme. Ça, c'est plus chaud quand même. Hein? Adulte, c'est compliqué, on est d'accord. Enfin, pour moi, en tout cas. OK. So, on attend, vous allez avoir la réponse. So, to answer this question with Ghislaine Dehaene, I mean, we did a near-infrared spectroscopy and EEG study, not simultaneously, but successively. So, we did high-density near-infrared spectroscopy in 28 weeks, 32 weeks gestational age premature, and high-density EEG on the same age using the same protocol. The protocol is this one. It's ba, 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 ba versus ba, 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 ga. And the ba and the ga can be male or female. So that's the result of the EEG. We have the ERP of the EEG, so it already can synchronize to a stimulation. And we have the near-infrared spectroscopy, and we looked at the mismatch. Can we have the video? So if you look at the video over here, you have the deviant phoneme, the standard, the deviant voice. Can we stop the video? No, we cannot. Okay. So if you look at the standard and the deviant phoneme and the deviant voice, you can see that different structures are involved. I mean, we cannot stop, but you will see on the next slide. So the response is yes. The premature neonate is able to discriminate between ba and ga, and male and female voice. Yes. 30 weeks gestational age. That means you plug the premature, and it can do it. So that means before 28 weeks gestational age, there have been development that allows this, the coding of this information. If we look at the EEG, I mean, we have also this is what the deviant voice and deviant phoneme. The mismatch is on the right side for the deviant voice, which is expected from adult study. And the mismatch is for the deviant phoneme is on the left side, which is also expected from the adult study. Of course, it's a bit, the delay is a bit longer for the premature than for the adult, but I mean, the treatment of it, the premature use the same strategy than the adult to code the information. And this in different areas, and the same area, the inferior frontal gyrus is involved in the detection of novelty. The left STS is involved in the treatment of phoneme information. So all of this suppose that there is a pre-wiring of the system. So there is a strategy which is already developed, which is already there, and the structure are also developed previously. So there is a strong genetic fingerprint for that, because it's just the time where you connect. So discriminate the mother voice from a stranger voice. Who says yes? Eh no. In fact, we don't know. I mean, but all of this, ba and ga, and male and female, this is, I mean, physical characteristic of the sound. For the mother voice, you have to learn the mother voice, because if your mother is smoking, for example, and stops smoking, she has a nice voice, blah, blah, blah. And so, I mean, it's not when you plug the system that it works. You need to learn, and it takes a bit of time to learn the mother voice. So this works in full-term neonates, but in preterm neonates, this is probably more difficult. I will. So there is difference. I mean, that's something we did with the Canadian. There is a difference in terms of at least localization of the response between the mother voice and the stranger voice for full-term neonates. But it's full-term, so I will not go in detail. To discriminate rhythm, we present to the premature neonates a different type of rhythm with omission or with shorter delay between the two last notes, the two before last notes. And as you can see over here on the green line on this side, there is a mismatch. There is a difference between rhythm for the coding of rhythm. So yeah, it can discriminate rhythm from 30 weeks gestational age. And we did then some frequency tagging to show that he was able to track for meter, double, triple, and quadruple frequency in the stimuli. And so yes, he is able to detect bit and meters frequency in the different rhythm. I think I'm short in time. Huh? So that's the end. So if we look at the structure, I mean, Jessica Dubois in Neurospin shows that there was some asymmetry between the right and the left hemisphere in premature neonates of nearly around the same age. We found that the endogenous generators and functional connectivity were already working before, I mean, the plug-in of the brain to the environmental world, and that there was something that was already developed and probably with a strong genetic fingerprint, but if there is a grain of sound inside this mechanisms, it can have developmental impact. Habituation and mismatch, this is a strategy that is already used, so that means also the strategy is already present. And discrimination for a lot of things which are the physical characteristics of the sound are already present. Wow. Did I do that by myself? so powerful. So at the onset of the thalamic connection, so when you plug the cortex, so the connection at 28 weeks gestational age, before learning, I mean, there's a strong genetic fingerprint, and the brain is not that immature. It's immature, of course, but it can already do a lot. Maybe this works as well. Yeah. Donc, en français, le grain de sable à différents niveaux, on a du grain de sable, a grain of sand, I mean, in wherever, but very early in the development, it can impact the development. It can have deleterious effect for the lifespan. So, spontaneous generators and la mise en place des réseaux, les activités stimuli dépendantes et le début de l'apprentissage, tout ça, ça se passe déjà à 28 semaines d'âge gestationnel. C'est déjà très très tôt, mais c'est probablement là qu'il faut aller chercher les informations, la manière dont ça se fonctionne, dont ça s'organise, et que le moindre grain de sable là-dedans, ça va être une catastrophe neurodéveloppementale. En français, ça va mieux quand même. Hein. Donc la question qui se pose, je peux finir en français? La question qui se pose, c'est quelle est la prise en charge adaptée? C'est-à-dire qu'on sait que les prémas sont des enfants à risque neurodéveloppementaux, et beaucoup. Et tous. La plupart ont quand même quelque chose qui dysfonctionne et qui va se révéler au fur et à mesure des apprentissages. La question qui est posée, c'est une question à laquelle je tiens, c'est les prémas, comment on les prend en charge? Qu'est-ce qu'on dit aux parents? Comment on fait? Est-ce qu'il faut les surstimuler, les stimuler, etc. Et tout. Je pense qu'ils sont capables de faire de la discrimination, et il faut les aider à faire de la discrimination. Mais il ne faut pas les surexposer à des stimulations. Le cerveau, il aime bien ce qui est complexe. Et il va travailler, il va se développer dans des trucs complexes. Donc la mère, il ne faut pas les priver, il ne faut pas les mettre dans des couveuses. Et c'est ce qui existe dans certains pays où on met les enfants. Il y a un enfant par chambre de 25 mètres carrés au silence, et il ne faut pas que ça bouge, il ne faut pas qu'il y ait de bruit. Non, il faut qu'il y ait du bruit, il faut qu'il y ait du son, il faut qu'il y ait des interactions, il faut qu'il y ait des choses comme ça, et il faut peut-être qu'il soit à 2 par chambre ou à 3 par chambre, mais pas en isolement. On fait pas de l'isolement pour les prémas. Et c'est un peu le message, c'est-à-dire c'est les aider dans leur capacité de discrimination, de manière soft et calme, mais faire en sorte qu'ils se développent. Maintenant, sur l'avenir de tout ça, c'est d'aller voir si on a des désorganisations des générateurs spontanés, ou si on a des dysfonctionnements du codage initial, et dans quelle mesure on peut les aider. On peut essayer de voir de manière précoce, d'identifier de manière précoce des enfants à risque de troubles neurodéveloppementaux, en se basant sur ces informations-là. C'est pas gagné, parce qu'il faut faire des grosses cohortes. C'est prétentieux, parce que après, peut-être ça dysfonctionne, mais il va y avoir toute la plasticité cérébrale qui va se mettre en place et qui va venir masquer en fait ces troubles initiaux, ces dysfonctionnements initiaux. Donc pour aller chercher les informations, ça va être compliqué, mais en tout cas, c'est notre ambition. Voilà. Merci.
Merci.
On n'a pas le droit de faire ça, c'est le Covid.
Delphine, oui, une question.
Donc, merci beaucoup pour ce topo. Donc, moi, je suis néonatologiste, donc je suis particulièrement touchée et sensible à tout ce qui a été dit. Donc, déjà, je pense que c'est quand même des notions là que tu viens de présenter qui devraient être un peu mieux diffusées, beaucoup plus diffusées au niveau des néonatologistes. C'est-à-dire que de plus en plus, on est en train de discuter l'abaissement du seuil de prise en charge des prématurés en France. On parle de 22-23 semaines. Or, il y a toujours effectivement des risques. Et alors, c'est d'ailleurs intéressant parce qu'on sait qu'après 28 semaines, ça va un peu mieux quand même. Et c'est marrant parce qu'on a déjà des choses qui sont mises en place au niveau cérébral. La deuxième chose, c'est on a fait de la néonate au début, on s'en fichait complètement de l'environnement de l'enfant, on le ligotait, on l'attachait parce qu'il ne fallait pas qu'il s'extube, le bruit, machin, on s'en fichait. Et puis maintenant, il y a le courant de soins de développement avec des écoles variables. Et donc certaines, et moi ça m'agace aussi, c'est-à-dire le cache sur la couveuse, pas de jour, le bruit, ok, les chambres seules, donc c'est ce que je vis ici à Tours, donc c'est sympa quand la mère est là, mais quand elle n'est pas là, en fait, l'enfant est tout seul, c'est une catastrophe. Et puis on les on les momifie, hein, parce que quand même, il faut les envelopper. Voilà, mais on ne sait pas qu'il faut les envelopper, certes, pour les rassurer, mais qu'ils puissent quand même bouger, etc. Donc c'est vraiment, ça a l'air, le problème, c'est qu'il y a des croyances qu'il va falloir vaincre. Et moi, je suis toujours en train de dire, mais là, peut-être voir un petit peu le jour. Je ne dis pas qu'il faut le mettre en plein soleil, mais peut-être enlever le cache-couveuse, ouvrir un peu les volets de la chambre pour que... Voilà. Donc c'est, je pense, des éléments à vraiment transmettre pour nos collègues néonatologistes et globalement les soignants, parce que finalement, c'est beaucoup les infirmières, hein, qui gèrent l'environnement de l'enfant. Et je pense qu'on ne fait pas bien pour beaucoup d'entre eux. Et quand même, l'autre chose, j'étais un peu déçue qu'ils ne reconnaissent pas la voix de sa mère. Je dis ça parce que justement, dans les soins de développement, quand même, le point positif, c'est qu'on met en avant le lien avec les parents, etc. Donc, il ne faut surtout pas le dire aux mamans parce que, elles vont être déçues. Et j'allais quand même poser une question. C'est qu'un enfant né à 24 semaines, qui a été habitué à la voix de sa mère ex-utéro pendant 4 semaines, jusqu'à 28 semaines, parce qu'elle l'a pris contre elle et qu'elle lui a parlé, est-ce que les résultats seraient le même? Voilà, faut tester.
Non, non, mais si. 28 semaines, avant 28 semaines, c'est pas connecté.
Oui, mais ça dépend si on est in utero ou ex utero.
Non, enfin, ça c'est une grosse question. Ça, in utero, ex utero, est-ce qu'il y a une différence entre in utero et ex utero? La seule personne qui peut répondre pour l'instant, c'est Hubert Prest, qui a fait ça en mec fœtal à Tübingen. Il retrouve grossièrement les mêmes générateurs que nous en EEG. Maintenant, est-ce que le décours temporel de ces générateurs est le même? Est-ce que ça arrive de la même manière? Est-ce que voilà, la reconnexion, elle est probablement la même parce que c'est sur des fœtus in utero que ça avait été fait. C'est Kostovic qui a travaillé là-dessus et qui a montré que. Donc, je pense pas qu'on ait de grosses différences sur la relocalisation des afférences thalamiques.
Mais par contre, par exemple, si on prend, alors ça n'a rien à voir comme tissu, encore que c'est de l'ectoderme. On sait que la maturation cutanée, par exemple, elle va se faire. L'enfant va naître avec une immaturité cutanée et on a une accélération de la maturation cutanée. Est-ce qu'on ne peut pas imaginer qu'en étant ex-utéro, avec des stimuli différents, on n'a pas une accélération de la maturation et des transferts de connexion?
Moi, je dirais l'inverse. Ouais, parce que je pense que le fœtus in utero, il est sollicité tout le temps. Enfin, je veux dire, sauf quand la mère, elle dort. Mais je veux dire, la mère, elle peut aller faire du ski avec un fœtus dans le ventre à 28 semaines. Il va bouger, il va entendre des bruits, il peut aller à concert rock, il peut faire tout ça. Il n'est pas si au calme que ça. Il est protégé, etc. Et tout. Mais il est dans une situation extrêmement dynamique. Quand on le met en réa, c'est ce que tu dis. Moi, je trouve que c'est mettre des enfants en privation sensorielle dans des couveuses. On doit se battre contre ça. Maintenant, 24 semaines. Tu posais la question des enfants de réanimation à 24 semaines chez les tout petits. On sait que c'est un problème éthique qui est catastrophique. Enfin, je veux dire, parce qu'on peut, après, il y a laisser les vivre, il y a tout ça qui va rentrer dedans, et donc c'est pas le lieu, mais on prend une grosse responsabilité quand même dans la ressuscitation en fait de ces enfants. Alors, moi, j'étais allé au Danemark, et au Danemark, ils avaient construit le Karolinska, dans lequel il y a une chambre par enfant, une chambre pour la nurse et une chambre pour les parents. Donc il y a 3 pièces de 25 mètres carrés. On n'a pas ça dans nos réanimations. Et puis quelques jours après, je suis parti en Iran. Et en Iran, ils étaient 14 enfants dans une seule pièce. Donc il y a un contraste entre les deux. Après, je suis revenu à Amiens. Amiens, c'est la plus belle ville du monde aussi, hein, je vous le dis.
Je vais être obligé de te couper.
Il n'y a pas que la néonate. Eh ben, on a 2-3 enfants par salle. Et ce que tu disais, c'est que quand il y a un parent qui ne vient pas, il y a le parent de l'autre enfant qui vient. Et donc, ils sont en stimulation sensorielle. Donc, il y a une limite, il y a une bonne organisation à trouver. Et surtout, pas avoir la prétention de dire qu'on connaît et qu'on sait comment ça se passe. Mais je crois que si on part du point de vue que le cerveau aime bien la complexité et que c'est là-dedans qu'il se trouve le mieux, il faut mettre de la complexité pour leur permettre de traiter des informations.
Merci beaucoup. Bravo encore.
Merci.